Hello and welcome to Science today. We are starting Unit 2, which is motion. We're learning new terms. The last few days they have had a couple different resources to go through, videos to watch. They were able to reflect on their old test, and today we're going to go over the terms force, acceleration, speed, velocity, position, displacement vector, and scalar. So all of the beginning terms down to vector were ones that they went over and should have ready for class, and I'm going to add the term scalar in class to see if they can build on that. This class is 25 honors students. This is a different class than the one that we normally watch. This class has one student with ADHD who's not on camera. If you watch the beginning of the video, he generally will write in the chat box saying that his camera and microphone don't work. He is very on top of that to alert us every single day in class, even though we have reached out to his family, and we do know that this is a problem that his family is trying to fix. This is not him in particular. He meets up after school in the support hour to talk to us, and he also has check-ins through his email daily to help out and make sure he is staying on top of his work. The challenge. Last time around, the videos that they were given had everything defined for them, so it gave them the term, the definition, the unit, and they had to come up with an example, and sometimes it would even give them an example. So it was a great way to introduce them to how to create these slides, but this time around, a lot of these things do not give them everything. So something may say the definition of speed is this, but it won't give them a unit, and it is their challenge to use their own knowledge, saying, well, I thought of speed as a car, and the unit for speed in a car is miles per hour, so I wrote down miles per hour. That's what I'm looking for in this lesson. Can they, without as much being given to them, figure out everything that I am asking for them using resources like the internet, their other peers in their class, maybe their parents, or reaching out to me if they need a little bit of help. So we are going to start the class and see how this goes today. Alright, hello everyone. Let's see, almost everyone's here. Oh, Ruby, do you have a fancy Harry Potter shirt on? Yeah, it's just like your question in the beginning. You asked about Harry Potter in your level 2 question, didn't you? Yeah, I remember that one. Alright. So everybody get out your force slides if you can. Or at least the slides that you created. You should have one for force that you created Monday. Tuesday we did speed, acceleration, and velocity. Wednesday we did position, displacement, and vector. Alright. So does anybody have a definition for what they put as force's definition? Anybody have one? Hannah, do you have a definition of force?
I put a push or a pull from an interaction from another object.
Awesome. I like that you have push and pull in your definition. That is a great example of what a force is, a push or pull. For mine, I wrote a push or pull on an object with mass that causes a change in its velocity, which was a little more, but these were terms, a term we already went over and a term we are about to go over. Did anybody have a unit for force? Yeah, Sean?
A Newton?
And why do you think it's a Newton?
I remember we were watching the video and it said that how many newtons or something about the force with, I don't remember exactly what it was, but something about that.
Awesome. Does anybody else have a guess why it would be a Newton? Colin, can you take a guess why force is measured in newtons?
Maybe because Newton is a unit of measurement, and also maybe because Isaac Newton discovered gravity and gravity is a force.
Yes, he had a huge part in helping us learn that theory of gravitational acceleration. Good job, thank you. As an extra note, I went through and I wrote the equation on mine as well, just to help show me. So force is actually equal to mass times acceleration. So an old thing that we had learned times a new thing that we are learning now. And looking at those two things, so the amount of matter plus that speed and direction is force, right? Which makes sense that we would define it as a push or pull on an object. Did anybody have an example for force? Yeah, David?
I put a human pushing a desk because I know that that's technically a human exerting a force.
Absolutely, good one. Okay then, so force, good job. All right, let's move into speed. Does anybody have a definition they used for the term speed? Nolan, do you have a definition for speed?
Yeah, let me find it here.
No problem.
Yeah, so for my definition of speed, I just said how fast something is moving.
Awesome. So I would add to that maybe just over distance, something like that. So I put for mine the rate at which an object covers distance. Did anybody have a unit for speed? Colin?
I have miles per hour.
Good. And when could you use miles per hour? What would be a good example of when to use that?
If a car is going 30 miles per hour, that's the speed of the car.
Awesome. So that'd be a great example for that. Did anybody think of a different example than a car for speed? Yep, a car is a pretty good example. I did like that one too. That was my example. All right, let's see here. So if we move into acceleration, does anybody have the definition for acceleration? Yeah, Aiden.
The change in velocity over time.
Yes. So velocity is important to that definition, and it's change. Yes. I put the rate at which an object changes its velocity. That was great. Does anybody have the unit for acceleration? Yeah, Sean?
Is it meters per second squared?
Yes, meters per second squared. What else had the unit meters per second squared that we went over? Casey, do you remember what had meters per second squared? No. When we went over gravity in our last unit, it's 9.81 meters per second squared. So, good job. And then, did anybody have an example that they used for acceleration? Ariana, did you have one? No problem.
I just kind of tried to draw it out with photos because I wasn't sure what to put really. So I just kind of had one of those pictures of the kind of like those mini maps with the vectors on it. So I did that for my acceleration.
That sounds pretty cool. I like that example. Even bringing in vectors, so a later term we went over. Awesome. Good job. Thanks, Ari. Okay, velocity. Did anybody get the definition of velocity? Allison, did you get the definition of velocity at all? That's okay. Do you have the unit for it at all for velocity? Maybe that's a little easier to type out. So does anybody want to help her out? What could be a unit for velocity? Oh, yes, Casey, thank you. Meters per second. Awesome. That's exactly what I had. So hopefully a couple other people's had meters per second. That was a good one. Does anybody else have the definition of what velocity could be? Lucy, do you have that?
I put the change in position over time.
Yeah. It's a good one. So, nice. For mine, I did speeding in a specific direction. So, meters per second forward. And did anybody have an example that they used for velocity? Liz, did you have one? Oh, Ruby Kim pushing on the gas in a car. I like that example, Ruby. Did you have one too, Liz?
I have to pull mine up first. Sorry.
No problem. Kids run right to the ice cream truck. Casey, I like that example a lot. Those are both really good ones I didn't think of. I did a 500-meter race because you just run straight to the end, right? You don't really curve or anything like that. Just go straight to it. I bet you had a good picture for yours then, Casey. Nice ice cream picture. All right. I'll give you a chance to pull those up, Liz. We'll move over to the position slide. Did anybody have a definition for position? Yeah, Jack, go ahead. Not sure if your mic is working correctly. Can't quite hear you. Oh, awesome. Thank you for typing that out. The location of an object. Yes. So I wrote something very similar. I said the location to a reference point. Absolutely, the location of an object. I like that. Now the unit for this one was pretty tricky, so I'm not going to make you guys figure it out, but I wrote for my unit, I wrote the x or y axis. So it isn't necessarily a unit, but something you could find. So on a graph, if you looked at the x or y axis, you found a point then that could be the position on a graph, which was also my example. Did anybody else have, Colin, I'm sorry, what were you asking? What velocity was equal to?
No, I looked what the unit for vector was, and it said like v equals something.
So there could be a lot of things. It depends on what we're calculating the position of. So if we were calculating velocity on a graph, on a speed or motion graph, absolutely. I see where you're going with that, and that's a good point. So yes, that one was very tricky. Did anybody have an example of what they put for position? Anything besides a graph? I liked your examples for the other one. Ari, what'd you have?
I basically said a graph, but I said battleship, like the game.
I like that example a lot. Yes, an exact point on that. That is, it's like a graph, but it's an easier way to see it. Carly, what did you have?
I put a bingo card because you have to like kind of say like coordinates to find which square.
Absolutely. That's a really good one. Yes, so you're going down and around. The connect the dots game. Oh my gosh, that's a good one too. You guys thought of really good examples. That one was a tricky one, and we came up with some fun ones. Does anybody else have one? Okay, so displacement. So displacement. Did anybody have a definition for displacement? Maddie, did you have one? Oh, going on a bike. Thank you, Liz. What's the unit for vector? Did anybody hear what I said? For vector, we haven't gotten to vector yet. We didn't go over that one yet, Mark, but we'll get there. But yes, go ahead, Maddie.
That was the wrong button. Okay. When something moves from its original position.
Perfect. Yes. An overall change in position. Displacement. So its placement is where you have put it, and displacement is movement from that original position. Good job. Does anybody have a unit? There's a lot of units. This is like distance, so it's just changing its location. What's a unit we could use for this? Kaylee, do you have a unit we could use for displacement?
You can use meters.
Yes, meters. That's exactly what I have too. So anything we used for distance, you can definitely use as a unit for displacement. Did anybody have an example? Displacement? My example was a leaf falling in the wind off of a tree because it kind of feathers down to the ground and kind of gets displaced as it's moving around. Alexis, did you have one for displacement at all?
I'm not sure if this really works, but I did like bike, like you could ride it from like your house to school.
A bike when you ride it from your house to school. Yes, you're changing your position. Good job. That was a good one. Colin, did you have one?
I had when someone moves to the back of an airplane.
Moving to the back. Ooh, that one's a good one too. Yes. Awesome. And then now we are on to vector. So Mark, are you there? Did you have a definition for vector? We can help you with the unit. Oh, Hayden had the same one as you, Colin. Nice. I know Mark wasn't able to unmute, but if you can write in the chat, we can go over that right now. We'll give you a minute. Direction of where you are going. Thank you. So yes, when we think of a vector, vectors are often drawn as arrows, where it has the head is the pointed part, and then the tail is the straight part of that, which shows its direction and its magnitude, how long that arrow is overall. So magnitude and direction is what's involved when we're doing a vector. And for unit, did anybody have a unit? Can anybody help us out here? So this one can be a little bit tricky if we have how far and the direction. So if you were in a car and you said you were going 40 miles per hour east, that would be a great example of a vector because that has magnitude and direction. 40 miles per hour east. Need to be specific there. So using that, if we had that as our unit, not every unit is perfect like meters is, but we would need all of those parts to have our vectors proper units. Does anybody have an example of what could fall under being a vector? Phoenix, do you have one? You're muted, Phoenix. That's okay. Can you write down an example or do you not have one? Oh, that's no problem. So for this, it may not be a specific example. I wrote down terms that we went over, which anything that falls under those terms you could definitely use as one. So I wrote force, velocity, acceleration, and displacement all fall under, you can draw vectors for force, velocity, acceleration, and displacement. And I'm going to put up these slides after. I'm going to add them to my own, but I wanted you guys to have a chance to go through and create your own slides before I gave these to you. And then let me go through and I will show you my screen here, and we can just go over those quickly one more time. So hopefully, can you see my force slide here? Oh, we'll go over it in a second, Mark. So can you guys see the force slide? Perfect. So this is what I had for force. Force was in the middle. I made it a nice bright color. The push or pull on an object, that's enough right there. But I put mass and velocity just so I could relate it to our other units we went through. My example was the force that pulls us to Earth's surface. And then a Newton, after Isaac Newton, right? He's very helpful. Force equals mass times acceleration. For speed, I did, my definition was the rate at which an object covers distance. I did a car, which I think quite a few of us did, with meters per second. You can also do that as miles per hour easily. That was a good unit. I think Ari helped us with that one maybe. Acceleration was the rate at which an object changes its velocity. And then meters per second squared, that one was a good call by whoever helped us out with this. And I did speeding around a corner, right? So changing your velocity, you're speeding up just a little bit. For velocity, speeding in a specific direction. So I did a race. I really enjoyed Casey's example of running to the ice cream truck. And Ruby had a good example too, which was, what was it? Pushing the gas in a car. Yeah, that was a good one too, moving forward. For position, the location in reference, location to a reference point. For the unit, I did the X or Y axis, and I did a graph. But for this one, you guys had really great examples like Connect 4, I think you went for, and also Battleship and Bingo. Those ones would be awesome ones to include in this picture. Really liked those. Displacement and overall change in position. We used meters. This could be a lot of different things. I did the leaves falling. Casey helped us with riding our bike somewhere. Hayden and Colin with moving to the back of a plane. Vector, the magnitude and direction. So 40 miles per hour east. And I even included this picture when I Googled what a vector was. I just used this little insert image and typed in vector, and this actually came up, which was pretty easy because then you can sit here and you can see the different terms written out. And then the examples I did were force, velocity, acceleration, displacement, and I did this cool picture of a car accelerating super fast. So there's one more term that we can go over Yes, another way to think of the difference between speed and velocity is the number of math problems you can do in 10 minutes is speed, because you are not moving in a specific direction, but it's still a rate. I did like that example. Thank you, Mr. Girl. And then there's one more thing that we could add today if we open up a new tab. So if you right click and do duplicate your last slide, or go to File and do Make a Copy, and then do Selected Slides and just do one slide. What goes along with vector? There's one other term that's very similar to this, and does anybody know what the very similar term to vector is without one of these? Did anybody hear that in the video at all? So that very similar term is actually called scalar. So it's just magnitude, so if we cut out the direction, then it would just be 40 miles per hour. So an example is speed, mass, temperature, and time. So this is the difference if you were to draw this out of a scalar versus a vector. Scalar, it's vector is going to be a lot more helpful to our unit. So this one wasn't one I had you do on your own, just because vector is going to be a lot more important to our overall unit. So Mark, did you get that unit as we went back through it at all? Perfect. Did anyone else need help on a particular slide? I will put these back up under Miss Losito's vocab templates later on. Perfect. So let's give you a minute to write this one down. And Brody's back. Awesome. Alright, so what we are going to slowly shift into is another simulation to help us review what we are going over with these terms. So that first day what we went over was speed, acceleration, and velocity. So those terms were very important to know the difference. So like Mr. Girl said, you can speed through a test, but you're not changing where you're sitting or moving during that time. So we have, let's see here, let me show you what we're working with here. Did it go dark for you? What?
So I just had something.
Oh, the internet went down.
Was the internet or the power? Like my whole thing here turned off.
Yeah, this turned off, but my
Power went off.
Oh yeah, the power went off. There you go.
Yep, this thing triggered. Our wonderful. Should come back on now.
Alright.
Are you still in class though?
Yeah. Alright, sorry about that, folks. Let's move into our simulation now. Alright, can you see the simulation at all? Perfect. So we're going to go through, and today we're just going to spend a little bit of time having getting to know this program, just playing around with it a little bit, and then tomorrow we will have a formal lab that goes along with it. So today, if there's any parts of clicking these things that you don't understand, that don't maybe make sense, then we are going to go over that. So this is, there's 3 different levels here. So there's a practice round, level 1, level 2, and certain death. Very ominous, right? And then you have these different ones here that you can click, and then this is your position. So the point is to get this into the finish. You want it to go straight. So if you click and drag it, so you change its position, and then you can start. and you can drag it until it gets there. So that was finishing the first round, but then there's other ones. So then you'll, which that was my time. You're timing yourself as you're going. So it tells you the time from getting that to there. So that was just moving this one. If we move this one and this one, you can reset it. And then if we go with acceleration instead, so these are our different things. We're changing its position, its velocity, or its acceleration. So these change how difficult it's going to be to move this. So if I send it moving like this, then it's only going to move with acceleration, so it's probably going to miss it and keep on going, right? So then that game was over and we had to redo it. But then as you get through the different levels, you have to avoid these obstacles, so you have to get it through without hitting anything. So if it hits a certain area, then you have to go back, touch it again. So if I were to do this one, let's start our game. If I were to go through and, oh, that didn't work as well. So there's a collision, so you have to go back through, fix the collision, and then go back through. So we can change its position, its velocity, and its acceleration. I will give you this game, but the whole time it is counting, so you can pause and redo it. And today is just for fun to get to know it, but then tomorrow our lesson will be on this. There's that simulation if you want to spend 5 minutes going through that. Right. So you can go through the different levels of practice, level 1, level 2, certain death, and then tomorrow we will have the challenge of filling out a lab as we go through and play with this different simulation using the position, velocity, and acceleration. And remember, you move things while you're in here. So, whoop, it hit there. So you have to go back, clear that, go back through. So for this game, it is going to be a little bit difficult to do this on the call, and I quite understand that. So tomorrow we are actually going to have a little bit of extra fun of having this where we're going to have a day that's a lot like Wednesday. So we will all check in together and have an attendance question, but because this has the lab attached to it, then we will have the fun of not being on the call at the same time, and we will post everything into the classroom and let you know a little bit more about that tonight in your remind and upload all of that. But you can always email us throughout the day to let us know any questions you have, and then there will be a little quiz too, but that'll be a different day. So go ahead and play this and ask us. I'm probably just going to have the game load the whole time. Yes, Hayden, it does take a while to load. Mine was loading for a little while too. Made the whole internet go down for a second. It was like Wreck-It Ralph in here. So yes, if you have any questions, please let me know if you're able to load this today. And was anybody able to go into Tyler yesterday and look at their grades for their extra Wednesday? Perfect, thank you, Ari, Sean, Maddie, looking at your grades. Thanks, Ruby. Perfect. So yes, make sure you're checking Tyler, not Google Classroom. Tyler is the most updated grade that you have. Alright, let's check in with a couple fun friends that maybe aren't on camera. Parth, are you doing okay? Write in the comments if you're doing good. Let's see here. Ava, you doing good? I do appreciate how many of you have your cameras on in this class. That's no problem, Ruby. So I will re-upload this fun thing tomorrow and we'll go over it again. You can send emails whenever you want, but another fun day with our successful first hour scientists here. Very, very good at getting all your homework done, turning everything in. You're very, very knowledgeable on all of your wonderful slides that you've created. I will update those on our Google Classroom, and if you want to take the last 2 minutes to log out of this class and then use that PhET simulation to try and see if you can get a little bit of it running today. So if you have questions, you can email us the rest of the day. But otherwise, you all have a great day, and I can't wait to see you again. Alright, as we saw, this was our first class of the day. A lot of these students sometimes show up a little bit tired. Maybe even once or twice they'll show up a little bit late. It is 8 a.m. when this class starts, and they are all at home, so they're kind of rolling out of bed, getting ready for school. They definitely rocked without as much guidance. They still did the same amount of work. Everything checked out. They did so well on this. A lot of them did question it, but then when they went back and looked at things, they had all the information they needed. They were using the chat box, they were unmuting. Almost all of them had their cameras on that were able to put their cameras on. They did great. Where the mess up happened, the internet went out. If you saw that little blooper in the middle there, the internet completely went out and we had to roll with the punches, take out a hotspot I had and get that going while we turned on and off the breakers to reset the power to the classroom and get it back up and get them back on schedule, understanding what their expectation was, even though class was delayed for a couple minutes. And I thought the video would stop recording, and I didn't realize that it actually did continue recording, so we did get our observation out of today. So I was very happy that the kids were still all in attendance and went with it as we had those technical problems. But I thought this would be a great one to show you that even though with these problems, class still went on and they did so well. So great class today, a lot of new terms, a couple little mess ups, but we did it in the end.